Today we will understand the concept of differential phase shift keying. We have already studied about binary phase shift keying and quadrature phase shift keying, and in both the methods we have seen that both the method have a single drawback, which is recovery of carrier circuit, and that recovery of carrier circuit needs a complex circuitry. In differential phase shift keying, that need of complex circuitry at the receiving end for the recovery of carrier is eliminated. That is what makes it advantageous over binary and quadrature phase shift keying. Here you can see the transmitter block diagram and the receiver block diagram. First we will understand the concept of transmitter of DPSK, that is differential phase shift keying. At the very first you can see the encoder block, which basically encodes the binary data which we need to transmit with the output data dt, and the output data is then multiplied with the carrier signal, and the multiplication of the output dt and the carrier signal gives the differential phase shift keying modulated output. Now how it works? There is a binary sequence which we need to transmit. First we need to take an arbitrary constant for this output dt, then first bit of dt and the first bit of binary data is encoded. Here we are using an XNOR circuit or XNOR gate for the encoder. The output of that encoder is then given to encoder again by giving a time delay of TB seconds. This is how it works. Then this DPSK signal at the receiving end is given with a 1-bit delay to this multiplier circuit, and then output of this multiplier is given to this low pass filter, which basically eliminates the high frequency components. In addition to the elimination of high frequency component, as you can see, it gives the output with a bit duration TB seconds. So basically it keeps the or maintains the bit duration of TB second of the received input signals. This signal is then given to the decision device. This decision device decides the output. This output is basically binary data BT. This BT sequence is decided with the help of a threshold value. This threshold value can be kept at a particular voltage level. Let's say, for example, bit 0 is represented by 0 volt and bit 1 is represented by 5 volts. So the threshold can be of 3 volts. If the output signal is above 3 volt, we will consider it as bit 1, and if it is below 3 volts, we will consider it as bit 0. This is how the whole process works. Now we will take an example and understand the concept of transmission. Let us say a bit sequence BT. Any bit sequence we can take. Let us say 1 00 0 1 1 0 1. Let us say this is the input data. For the output dt, first bit we need to take any arbitrary value. Let us say 1. So now this one and this first bit of the bit sequence will be XNOR'd. Now what is the output of XNOR? If the bits are same, that is if the input is 1 1 or 0 0, the output will be 1, and if it is one input is 0 and another input is 1, then the output would be 0. So same bit XNORing would be 1, different bit XNORing will be 0, same bit 1, same bit 1, same bit 1, same bit 1, different bit 0, different bit 0. This is what the bit sequence. Now we will write the phase, that is the phase angle of dt, phase of dt. So bit 1 is represented with 0 degree and bit 0 is represented by 180 degree. As we know that from 1 to 0 or 0 to 1, it gives a 180 degree phase shift. So if we keep the phase of bit 1 as 0, then obviously the phase of 0 will be pi. So it is 0 0 pi 0 0 0 0 pi and pi. These are the phase angles of bit sequence dt. Now going to dt minus 1. That means we are giving a 1 bit delay to this bit sequence dt. So this bit 1 will come here, and accordingly every bit will shift to its next bit. So it will become 1 1 0 1 1 1 1 0 and 0. And finally this bit will be discarded, as we need only 8 bits. So this 9th bit will be discarded. So same way, now we will write the phase of dt minus 1. So again, for bit 1 it is 0 0, for bit 0 it is pi, 0 0 0 0 and pi. Now we will compare the phase of dt and dt minus 1 by comparing if both the phase are same, whether it is 0 0 or pi pi, it will be bit 1. And if the phase are different, that is one bit is having phase 0 and another bit is having phase pi, then the output would be 0. Accordingly we will write the sequence, which is here the phase are same, so bit 1 phase different, 0 phase different, 0 same phase, 1 same phase, 1 same phase, 1 different phase, 0 same phase, 1. So this is the detected output, this is the transmitted data. As you can see, transmitted data and detected output both are same. So this way, at the receiving end, we can detect the transmitted data successfully without the need of complex circuitry for the carrier recovery. This is how your DPSK signal works. Finally, the advantages and disadvantages of DPSK. The advantages of DPSK are: DPSK does not need carrier at the receiver, so the complex circuitry requirement is reduced. Another advantage is bandwidth required for DPSK is reduced as compared to BPSK. The disadvantages are: probability of error is higher, noise interference is more, DPSK needs 2 successive bits for its reception, so error in the first bit creates error in the next bit and the error will propagate more. These are the advantages and disadvantages of DPSK.